Hello everyone. Today I am going to tell the solution of this problem. This is case-based question which is an application problem based on similarity of triangles. Generally case-based question will give for 4 marks, that is 4 questions they will give. Each question carries 1 mark. So you have to minimize the steps here because 1 mark means you will get very less time. So you have to minimize the steps. Let us go through the solution, then you will understand how to minimize the steps here. Here, the problem is Rohan is very intelligent in maths. He always try to relate the concept of maths in daily life. One day he is walking away from the base of a lamp post at a speed of 1 meter per second. Lamp is 4.5 meters above the ground. So here the figure is also given. In case-based question, you have to observe the figure very well. So if you observe the figure here, this is the lamp post and the height is given, that is 4.5 meters. And Rohan speed is 1 meter per second. That means in 1 second he can walk. Rohan's walking speed, that is in 1 second he can walk 1 meter. So in the first question, if after 2 seconds length of shadow is 1 meter, what is the height of Rohan? So after 2 seconds, that means he is walking from the lamp post towards like this. So after 2 seconds, that means he reaches at this point, that is D. The shadow length is this one, that is given 1 meters. After 2 seconds, the distance you have to calculate, that is BD. So here 1 meter is given, 4.5 meters is given. You have to find the height of the Rohan, that is CD. So if you join these 2 points, then you will get a big triangle here. And here, this is a small triangle. So if you observe these 2 triangles are similar triangles, so you can equal the corresponding side ratios based on similarity of triangles. Because you have to find the, here this is the side of a small triangle, because this is the side, this is height of the Rohan. So if you apply similarity of triangles, you have to find this distance. You know this distance and this distance, you have to find this, and again you have to find this. By using the speed of his walking, then you can find the distance here, BD, because 1 meter per second, that means in 1 second he can walk 1 meter. In 2 seconds, he can walk 2 meters. You can directly calculate like this, or you can apply the distance formula. Distance is equal to speed into time. That is, speed is here 1 meter per second. 1 into 2, that is in 2 seconds, 2, that is equal to 2 meters. So here BD is 2 meters. Now apply the similarity of corresponding side ratios are equal. So here 4.5 meters. This is the side of this big triangle. And this is the side of corresponding side is CD. By CD is equal to, again you have to take this side 2 plus 1. That is 2 plus 1 by the small corresponding side is, small triangle's corresponding side is 1 meter by 1. Therefore, if you cross multiply this, 3 CD is equal to 4.5. CD is equal to 4.5 by 3, that is 1.5 meters. So, here the height of Rohan is 1.5 meters, that is CD. Like this, you can minimize the steps. This is second question. What is the minimum time after which his shadow will become larger than his original height? So here you have to find the minimum time taken for the shadow which is larger than his original height. So his original height just now we have calculated, that is 1.5 meters, and the shadow should be larger than his original height, means you have to calculate the time exactly for this height uh, distance, that is 1.5 meters only. So you have to take this distance, that is DE is 1.5 meters, because this is larger than his original height. So you have to take minimum time you have to take. So you have to take 1.5 meters only here. And here the time taken you have to find. That means BT, the time taken for this distance, T is equal to how much? Same like that, similar to the previous question, you have to apply corresponding sides ratios here. So 4.5 by 1.5 is equal to, here BD plus 1.5 is distance. Then from this 1.5 you can cancel. Then BD plus 1.5 is 4.5. Then BD is equal to 3 meters. So once you find the distance from here to here, B to D, then you can calculate by using the distance formula. That is T is equal to D by S. That is equal to, here D is 3 meters. That means here this distance is 3 meters. 3 by S is 1. speed is 1 meter per second. So 1, that is equal to 3 seconds. So from here to here, the time taken is 3 seconds. The next question is, what is the distance of Rohan from pole at this point? So here you have already calculated the distance of Rohan from the pole at this point. At this point means at D. So the distance here we have calculated is 3 meters. So in this time, for this shadow, you have to find the distance here, this distance that we have already calculated 3 meters. So here directly you can write BD is equal to 3 meters. Next question is, what will be the length of his shadow after 4 seconds? Okay. So here the height we know 1.5. This is fixed and this is also fixed 4.5. So here you have to find after 4 seconds. From here to after 4 seconds, you have to find what is the shadow length. That means DE you have to find. So here you can apply, first you have to find BD because you know the speed here. So BD is equal to speed into time, that is 1 meter per second into 4 seconds. You have to find after 4 seconds. So 4, that is equal to 4 meters. So here BD is equal to 4 meters. Once you calculate BD, then you can easily calculate DE. So apply the corresponding ratio, corresponding sides ratios are equal. So 4.5 by 1.5 is equal to, here this is 4 plus DE by this is DE. Then cross multiply, then you will get 4.5 into DE is equal to 1.5 into 4, that is 6 plus 1.5 DE. Then 4.5 DE minus 1.5 DE is 3 DE is equal to 6. Therefore, DE is equal to 6 by 3, that is 2 meters. So, here DE is the shadow length after 4 seconds. So, the position of Rohan is here and this is the shadow length. So, after 4 seconds, after 4 seconds, the shadow length is 2 meters. So, like this, you can minimize the steps and you can draw every time each each triangle like this, or you can do the same solution in one triangle. From this question, you will understand if the time is 2 seconds, then the distance is 2 meters and shadow length is 1 meter. And if the distance is 3 meters, then 1.5 meters, 4 meters. If the distance is 4 meters, then the shadow length is 2 meters. So from this, you will understand if the distance will increase, then the shadow length also will increase. You can see again here, if it is 4 seconds, that is the shadow length is 2 meters. And here 3 seconds, 1.5 meters. And here 2 seconds, 1 meter. So it is like that. So if the distance will increase, the shadow length will increase. Now, please practice these questions. These are the answers.